if I take this, if this is 1 radian, this length right here, or the angle that creates it is 1 radian, and I go around one more time, this would be 2 radians to here. If I go around again, this is 3 radians to here. If I go around again, this is 4 radians. This is 5 radians. This is 6 radians. And this is about, it looks like about 0.28 of a radian. Right around there. So going around the circle, if I created the angles, so this angle measures 1 radian. If I went to here, this would be 2 radians. This is 3 radians, the angle that opens up to include that arc. If I go all the way around the circle, it's 6 plus this little extra, which looks like 0.28. So it's a total of 6.28 radians. How many degrees go around the circle? 360. Does anyone know what 6.28? Has anyone seen that number before? It's 2 pi. This number here is 2 pi. That's the same as 360 degrees. Okay? What's interesting about a radian is there's actually no unit to it. Even though we say 2 radians, there's actually, it's not like a degree or like 3 feet or like 7 inches. There's actually no unit to it. It's actually a ratio of side lengths. So with that, it keeps all the numbers cleaner when you're doing all these calculations. You actually don't have to keep this unit in it. So that's why all the calculus we're going to do is in radians. And we're going to see and work with this later, like what you would have to do if you did want to do these measurements in degree. But it's helpful to not have a unit when you do a lot of these calculations. So a lot of this work is done in radians. Okay? When we go around and measure these angles, we've typically seen all the SOHCAHTOA stuff, all the trig stuff, just within a right triangle. What we're going to do is extend the right triangle. You can stay right here with your right triangle. We're going to start in an XY plane called standard position. We're going to start on the positive x-axis, and if we go counterclockwise, those are going to be positive angles. Positive angles, we're going to go counterclockwise. If we go clockwise, we're going to call those negative angles. And we're just going to spin this little spinner around. And wherever we stop, we're going to make a triangle. So we're going to go back to right triangles after we spin the thing around. Okay? So if we wind up over here, we just spin to here through some angle. I'm going to stop. I'm going to create a triangle on my XY plane. This length here, I'm going to call the x length of the triangle, the right-left length. This length here, I'm going to call the up, down, or y length. Now I'm just going to call the length of the spinner, the thing that's going around, or the hypotenuse of the triangle, I'm going to call that r for now. Okay? And with that, and that information, I'm going to look at the 6 basic trig functions. You got sine, cosine, and tangent, SOHCAHTOA. Sine is the opposite over the hypotenuse, or y over r in this case. The cosine is equal to adjacent from this angle right here. It is equal to the adjacent over the hypotenuse, or x over r. And the tangent is equal to opposite over adjacent, which is y over x. And those are the 3 that we've dealt with a lot. Well, they also have, there's another 3, because that's only 3 of the proportions you can talk about in a triangle. If you talk about the opposite over hypotenuse, you can also talk about the hypotenuse over opposite. And we named that cosecant. The cosecant from an angle, the proportion, is the flip of the sine. It's equal to the hypotenuse over the opposite, or in this case, r over y. If we look at adjacent over hypotenuse, you can also look at the flip of that, and we call it it, the secant. The secant is equal to the hypotenuse over the adjacent, or in this case, r over x. And then tangents, opposite over adjacent. The cotangent is adjacent over opposite. Those are all the 6 ways you can look at all the different proportions in a triangle, all the side length proportions. Now for me, I had trouble remembering this, because I would think that the secant's the flip of the sine, and the cosecant's the flip of the cosine. Is anyone with me on that? That would make more sense, right? So do you not want to know how I remember? It's not what it should be. If I think, what's the flip of the sine? Well, it should be the secant, but it's not what it should be, so it's the cosecant. Remember it. Maybe you can just memorize it. You're a lot smarter than me. That's what I needed to use. So if I ask you a question like this, if I say, what is the secant of 30 degrees? You don't say, well, what you do say is, okay, the secant is the flip of the cosine. It's the flip of what it's not what it should be. But you don't put in inverse cosine. Because what does inverse cosine do from yesterday? What's that? Yeah, it's the inverse function. This is the same as 1 divided by cosine of 30. The secant is the flip of the cosine. If you wanted to know the actual value, you do not hit cos inverse. Because what cos inverse does, it's inverse function, you have the proportion, it'll give you the angle. If you just want to flip it, you literally just have to flip it. So if you want to know what the secant of 30 degrees is, you do 1 divided by the cosine of 30 degrees, which is, anyone? Are you in degrees? It is? Okay, give me one more decimal.
4.
Okay. Everything give me 3 decimals. Okay? Same thing if you're in degrees. Right.
Should be 5.
You okay? All right. If I wanted to graph the cosecant of x function, if I wanted to see it on my graph, what you would do is question. You good? Under y1, you would just put in 1 over. Okay, cosecant is what? What's the cosecant? It's not what it should be. So it's 1 over the sine. Okay, and then you can graph that. If you want to see a graph of what the cosecant of x graph looks like, you flip the sine. Again, you don't put in the inverse or anything like that. Okay, does that make sense, you guys? Okay, and if I wanted to answer, when is the cosecant of x equal to 7? If I wanted to answer a question like this, on your calculator, you can graph the cosecant on y1, on y2, graph 7, and find the intersection point. Does that make sense, you guys? Okay, things to think about. Alright, so on these graphs, and we're going to look at them more in a second, the period of the sine and cosine is 2 pi, or 360 degrees. And the period of the tangent and cotangent is pi, or 180 degrees. Okay? Now we talked about even and odd functions a couple days ago. What does it mean to be an even function? Symmetric, even functions, or symmetric over the y-axis, which means what? What's the technical term? It folds like a chalupa. Technically, it folds like a chalupa would be the technical term for it. So, the cosine graph is even. So here's a graph of the cosine. Does it fold like a chalupa? Is it symmetric about the y-axis? This goes here, this goes here. Yeah, that is a symmetric about the y-axis. The cosine is an even function, okay? The sine and the tangent are odd functions. And here's a picture of a sine. You guys see it in all of its glory?